Hi, in this video we will learn about basics of systems of linear equations. Mostly the terminology will be introduced and we will see some examples of system of linear equations. Um Let me start with very first word you see here, linear equation. What is a linear equation? Well, we call an equation linear equation. So a linear equation in, well, n variables x1 x2 up to xn is an equation that can be written as, well, we have x1, then x2, and up to xn. So each one of these guys are going to be multiplied by a constant, and then they are added and then equal to another constant, where a1, a2, an, and b are constants. Well, in this case, what we call this a1 up to an's the coefficients, and this b we call it the constant term. Well, for example, equation like 2x plus y equals to 10. This is a linear equation. 2 times x, 1 times y, add them equals to 10. But something like x squared plus y equals to 10 is not, because here we have power for x. Or we cannot have something like xy plus z equals to 2. Here x and y are multiplied. In the form that you see up there, there is no multiplication of coefficients. No, so variables, sorry. Or something like, well, root 2 times x plus sine of, say, pi over 10 y plus 2 to the power 3 z equals to 1 is a linear equation. Well, the coefficient of x here is a1. This is a number. Well, it might be complicated number, but, well, it is at the end a number. For y, it is sine of pi over 10. For z is a3. But if I have something like e root x plus y minus z equals to 1, this is not acceptable because we are not allowed to have root of x. Or something like x plus sine of y minus z equals to 1. We are not allowed to have sine of y. Sine of a number times y is okay, but sine of y is not. And the same way we cannot have something like 2 to the power z. These are not acceptable. One more, this we cannot have like 1 over y plus x equal to 1. This cannot be. Although 1 over 2 times y plus x equals to 1 is acceptable. And these are linear ones, but this other column is, are not linear. Well, some small things to note here is that remark the form we mentioned above, if you apply in the case n is 2, we will have something like ax plus, okay, let me write as it was above. So ax plus by plus c, a constant multiplied x plus constant multiplied y equals to c. This is an equation for line in R2, yes. So two variables that will give you, or in case this is 3, we have ax plus by plus cz equals to t. This is plain. Well, in Rn, actually these are both in the general form, yes. So you see that this works. The linear equations in dimension 1 and 2 and 3 are the ones we already worked with. And while in the higher dimensions there are objects called hyperplanes, so every equation, every linear equation defines a hyperplane in higher dimensions. Okay, so that's linear equation. What about the a system of linear equation? What is a system of linear equations? Well, you will see me writing SLE, system of linear equations. Well, if you have one linear equation, it's one linear equation. If you put a bunch of them together, this is called a system of linear equations. So a set of finite linear equations is called a system. It's not just one, it's a system of linear equations. Something like, example, something like x1 plus x2 equals to x3, and then x2 minus x3 equals to x1, or something like x plus 2y minus z is equal to 1, and then x minus y equals to 2. And well, we can have more equations. For example, x plus y equals to 1, x plus z is equal to 2, x minus 2, z minus 2y is equal to 3. So these are examples of this, guys. And another thing here, an interesting fact to learn about, is that remember that when we had remark, when we were learning lines in R3, there were 4 forms for lines in R3, yes. One of these forms were normal form for lines. So the normal form equations for lines in R3 it is a system of linear equations. Well, remember how was that? So n1 x n1 dot x is equal to n1 dot p1, and n2 dot x equal to n2 dot p2. These guys, each one, if you open it, if you write them, each one will give you an equation in xyz, linear equation in xyz, and together they will define a line here. Well, now we have there are two linear equations, and that means these are so-called system of linear equations. There is something called coefficient matrix. Coefficient matrix, and what is called augmented matrix for a system of linear equations. What are these guys? Well, what is a system of linear equation? We know that system of linear equation, we can write it like this. Well, there is a first equation. So we have a1 times x1 plus a2 times x2, and this goes up to an times xn equals to b. If I want to write m of these equations, what will happen? I will put index the coefficients of first equation by a1, a1, 2, a1n, and b1. For the second one, this will be a2 1x1 plus a2 2x2, and this will go up to a2n xn equals to b2, and this will continue. How many equations we have? M equation. So we will have these guys, a m n xn equals to b. Well, this is a system. Let me just write here. A system of linear equations with n unknown and m equations. Well, from this we can get two matrices. One is, so let me just copy this guy and copy and then paste. One is that, okay, so you have this thing. Let me put it here, copy another one, paste it here. Okay. The first one is that when you order everything correctly, so the coefficients of x1s are aligned and x2s are aligned and constant terms are aligned, then what you can do is just ignore x's. Here. Okay, and then there's no sum. Okay, then put all of these guys in an array of numbers. This is called the matrix of coefficient, or the coefficient matrix. If other than coefficients we want to include the constant terms also, in that case we make something called augmented matrix. Oh, I'm deleting too much. I will fix that. So this is A, and this is A, this is another A. So what we do is that we put all of them in the matrix, but put a line, separating line between the coefficient parts and the constant term parts. This is called augmented matrix of the system. So we will work with these ones. Let's just do one example, two examples to see how this works. For example, if you have system of x1 plus 2x3 equals to 1 and x2 minus x3 equals to x1. Well, you can write the coefficient matrix and augmented matrix. The first thing is that you have to put them in a good order, meaning that all x1s, all variables are first one side and all x1s are aligned in different equations. So this one I take to the other side. Here there is no x2, so I won't write that. Plus 2x3 equals to 1. Here minus x2 plus x2 minus x3 equals to 0. Now from this you right away see that I have 1 0 2 1 0 and then negative 1 1 negative 1 as the augmented matrix, and the coefficient matrix is just 1 0 2 negative 1 1 negative 1. So these are just very basics of a system of linear equations. We will learn more about this thing. Specifically, we will learn how to solve systems of linear equations.